Okay, Roger, so this is our system, right? I mean, this little thing in this big house is our system. What's the most important thing that you have to keep in mind when you're installing one of these?
The most important thing is the static pressure, like you say in the previous video. The larger duct you can put to bring air to the return, and the more you can move around the house, it's gonna be better than having like a huge system with a small return. You're not gonna be so many CFMs in the house, and that's about the most important.
Well, I can see you've taken a lot of time to like insulate the actual cabinet, and just so that we know, this is our return plenum. This is a custom made piece, and this is an 18-inch duct on here. This is a 12,000 BTU system. This 12,000 BTU system is only going to move about 400 CFM of air. If you look on your little ductulator that some of you guys might own and look at 400 CFM, we could really do that through like a 12-inch duct. But we're going to have a lot of velocity. So we use these big 18-inch ducts, so this system has no problem moving the air through. We want to keep the static pressure really low. That's going to keep it very, very quiet. This is going to be a silent system when it's all done. Over here we have another custom-made supply plenum, and this is the actual appliance itself. This is our slim duct air handler, and you notice that we've sealed and insulated the slim duct air handler as well. That's important because attics, let's face it, are not the most hospitable location in the world, right? This is our duct system over here. With this system, all the ducts are pretty straightforward. We've got 4 runs coming off. They're fairly straight. Everything's going to be fine with this one. We're gaining a lot of static pressure benefit on this end, so we can have a little bit over here. This system's going to provide about 400 CFM, like we talked about. It's divided up around 4 rooms. It's going to be hugely quiet, like we said. And once we get done, we're going to take more insulation, like you see all this cellulose in here, which is a beautiful cellulose insulation. This was a newspaper at some point, which is weird. We're going to take and blow over this ductwork. This ductwork is R8 material, so it's already starting out pretty good, but we're going to get it up to R30, and that's part of the secret, right? So when this attic is 135 degrees, I don't have to recool these ducts every single time because this unit runs more continuously. It's not going to have a lot of load keeping those ducts cool because these ducts are going to be about R30 when they're done. So that's going to make a big difference as well. Also, we're going to have a really good shell, right? So we have R30 up here. Then we already have R30. We're going to have R30 more. So we'll probably end up getting in the 50s. But what that means is that I've got a 50-degree difference between the attic temperature and the house temperature before energy really starts flowing through there. So I've really made a good balance of not having to radiate the temperature from the attic down into the space, so we can use a really small system to take care of it as Mother Nature is adding a little heat. This will speed up and take care of it. The secret around these systems is it's kind of set it and forget it. You put the thermostat on what you like. It conditions the space to that temperature using whatever variable capacity it needs to, and once it hits that temperature, it really slows down. So when it slows down, it's using just a fraction of the energy it does when it's fully running in full speed. And with that, it changes the temperature of the air going in, so it keeps the downstairs exactly the temperature we want it. As Mother Nature kind of hits us in the side and puts a little heat in there, this system speeds up just slightly or slows down depending on what season it is, and takes care of that additional load. So it always keeps the temperature the same in the house. The outdoor unit just speeds up and slows down. So this is not like your typical system that's going to turn off and let the house get hot again and then turn on. This one's going to always keep it the same and use a little bit of energy doing it. Let's go check something.